Last video I showed the frame outline for my CNC router, and in this video I will continue to build the motor mounting parts and motor installation. Hi, welcome to Slow Engineering. I'm David. There are two parts about the motors. The first part is the motors for axis. The second part is the spindle motors for cutting and grinding. Start from the first part, the motors for axis. These motors drive both screws to perform axial movements on 3 axes. There are two options for the CNC router: stepper motors or servo motors. They all can provide position control. For the first build, I plan to use the spare steppers for my volume printer on the CNC router as a cheap solution. It will be convenient since the 3D printer mainboard with modeling firmware can also be used. If the stepper approach is not enough for the demanded accuracy, I might turn into using several motors in the future upgrade. The designed motor mounting part is based on the mounting holes on the steppers and the holes on the bolt screw support parts. The mounting part is designed with two combined materials as before to provide stiffness and create performance. They are spaced by 4 15mm tubes. 4 long screws will go through the tubes and fix the mounting parts to the bolt screw support parts. Both motor mounting parts and bolt screw support parts have alignment grooves to help align the tubes. In addition, the motor mounting parts for the Z-axis has an arm for the cable chain later. Untighten the coupling at the bolt screw side when installing the steppers. After installing the steppers, check the coupling is free to rotate on both bolt screw side and stepper side. Adjust the position of the stepper to make coupling rotate freely. Then tighten the coupling. The resolutions of this setup can be calculated by the steps of the 1.8-degree stepper, microsteps from stepper's drivers, and the bolt screw lead. The lead of the bolt screw is 10mm. If the stepper drivers can provide 32 microsteps, the final resolution will be like this. It seems okay in theory. If the loads on the bolt screws cause obvious inaccurate movement, the open loop control would not be suitable. In this case, the servo motors with encoder upgrade would be necessary. The second part, the spindle. I start from the cheap brush motors as the spindle with ER11 collet. The mount is also custom designed with the outline of the motor. As a fixed part for the spindle, the mounting part comes with PA12CF cord ABS. On the slicing software, Cura, I managed to make the PA12CF infill into a whole piece inside the parts to provide more stiffness. Tuning the wall counts to make the infill into a piece. After printing 2 motor solid parts, place the motor between 2 parts. Then, use long screws to install the entire motor parts onto the tool platform to finish the motor assembly. This is the motor assembly sequence and some thoughts for the future build. I hope you enjoyed this series. Like, share this video and subscribe to this channel if you learned something. Or consider becoming a Patreon member to support my projects. Click the pictures on the right side to watch more videos. Thank you for watching and see you next time.